All right, so here is our experiment, at least the preparation of the solutions. What I have here is a small beaker of our unknown hydrochloric acid and another small beaker of our unknown acetic acid, and then I've got my reaction vessels. Into each of these reaction vessels, I need to add a 10 mil, very accurately, a 10 milliliter aliquot of the unknown into our system. So I use my pipette and bulb. I have already rinsed these pipettes, but I'm going to go ahead and redo that. Set up my negative pressure, and we'll draw hydrochloric acid up into the pipette well above my desired target, and then we'll just let that drain back in, kind of rinse out the pipette. Okay, now you may recall that this pipette, just like all other pipettes, has a very, very narrow column here, which is going to set up a pronounced meniscus. We're going to measure this to deliver line here with that meniscus sitting right on that line to give us very, very accurately. In fact, we could quantify it as 10.00 milliliters. If I go beyond, I can always let some out. If I fall a little short, I can come back. Okay, now I have to crouch down here. It looks like we are right there. I lucked out. Let's go ahead and dispense that into our system. Remember, I'm using the little side ball up on the pipette bulb to allow atmospheric pressure to equalize in the pipette, and therefore it'll drain out. And there will be a small amount left at the bottom of the pipette. And this is calibrated. It's a ground glass tip, and it's calibrated to leave that just that tiny tip in there. Okay, so now my hydrochloric acid is set up. I have to do the same thing for the acetic acid. Let's draw some up into this and kind of rinse out the pipette a little bit. I've got some bubbles in there. I'm going to go ahead and blow that out just a little. See if I can get rid of those bubbles. That'll make it hard to read the meniscus if we have those bubbles in there. Okay. Got my target. Let's draw. And once again, I want to set that meniscus right up on top of that to deliver line. I want like a shot over it just a touch. There we go. And again, this will leave a tiny amount in the tip of the pipette, and that is actually desired, quantified. All right, I have my two systems set up. Let's take those over here. I'm going to set the acetic acid off to the side for just a moment. We'll deal with the hydrochloric acid first. Now, I've got a stir plate set up. Each of these systems, the hydrochloric and the acetic acid, already had a stir bar in place. Now I'm going to set up my pH probe, and we'll monitor the pH of these things in real time. Now this gets a little tricky because I've got the stir bar and the pH probe, and I'm going to have to ultimately put in the burette. So I've got this pH probe very, very close to the bottom of the beaker, but not so close that it interferes with the stir bar. Let me turn the stir bar on here. Okay, let me wake up. I've already started the LabPro system here. Let me see if I can wake this up. Okay, we're getting a real-time monitor of our pH, which, as we would expect, is very, very low because I've added water into this system, or excuse me, added hydrochloric acid into this system. Okay, I have filled my burette with the standardized sodium hydroxide, and I've got it sitting right on the 0. I'm hoping you can see that. Put that up here, and we want to place the tip just down inside the beaker so that we don't get a lot of splatter. Okay, before I start adding, I'm going to record this pH by hitting collect and then keep, and my starting volume is going to be 0.00. Now this system will truncate down to just 0 when it enters the data. If we look up over here, you can see the volume at 0 and a pH reading of 2.35. Now what I'm going to do is I'm going to add an amount, probably about 1 milliliter increments for a little while, and we'll watch that pH raise. So let's go ahead and start adding this. I'm just going to go real close to 1, and I'm going to take a reading here of the burette. I'm going to have to lower this just a little bit so I can see it. And it looks like we're at about 1.14. Remember to interpolate, 1.14. And you'll notice that the pH has hardly moved at all, so I'm not even going to register that. Let's go ahead and add another milliliter. Let's take it up to the 2 mil mark and see if that gets us anything. That's at about 2.08. Now it looks like the pH has moved, but ever so slightly. I'm going to go ahead and add some more. And this time we'll make a reading just in case here. All right, this is now at 2.41, which happens to be the pH. Isn't that interesting? Okay, I'm going to keep this. Volume is 2.41, and it just so happens that the pH is there. That's purely happenstance. That never happens. All right, let's go ahead and add some more. Do about another milliliter. There is 3. Let this thing stop vibrating. Points right on the 0.5, 3.50. We'll keep that. Let's add another milliliter. There's just beyond the 4.5. We'll call that 4.51. Let's let our pH stabilize a little bit. There we go. What did I just say? 4.51. That's about 5.53. Okay, now the pH is starting to come up a little bit more noticeably. That is 6.43. Okay, now that the pH is starting to rise, I'm not going to add quite so much with each increment. A little bit less than a milliliter. That's at about 7.39. That's right on the 1, 8.10. Take a look at my pH and see how we're doing here. Okay, it's coming up. As I get closer and closer on my pH column to 7, I want to start going very, very slowly. As we get close to that equivalence point, you'll notice that the pH will start rising very quickly with a very, very small amount of sodium hydroxide added. Okay, that is 8.78. Okay, now it's having a little bit harder time equilibrating. If you're watching these numbers, they keep climbing, albeit slowly. 8.78. small addition this time. Notice that pH climbing. It's going to take a little while to equilibrate until it really settles, stops changing dramatically. Okay, let's take a reading. Looks like 9.10. Okay, I just did a very, very small add, and our pH is climbing. Might add just a little bit more here. I want to see if I can get that up close to 6 for this run. It's getting there. While that's trying to equilibrate, I'll take a reading, and it looks like we are at 9.28. Yeah, that's going to make it to 6. 9.28 is our volume. This is the part that's like paint drying. You'll notice that this pH number keeps creeping up as things go into solution and distribute. And always keep in mind, when we look at pH, what we're looking at is the concentration of a hydrogen ion in the system. Okay, we pretty well stabilized here. 9.28 was my reading. I'm just going to add a single drop if I can and see what that does. That single drop is making the pH value rise. And remember, we've got a total volume here that's probably about 70 mil by now, maybe 75 milliliters. And a single drop is changing that concentration. Even though it's just a small change in concentration, we're right near that equivalence point, that pH of 7, to where it's rising the pH very significantly for the small amount of volume that's being added. So we are now past the equivalence point of 7. That equivalence point is going to be important when we do our analysis, and we'll use the graph to more accurately find that equivalence point. just keeps on creeping up. You can't be patient enough at this step. Alright, I'm going to go ahead and enter in my volume, and it looks like that volume is at about 9.38. Notice the large jump in pH from about 6.3 up to 6.8 and still climbing, with a very, very small addition of the sodium hydroxide. Go ahead and add in a little bit more. And watch that pH continue to climb. Now, of course, it's climbing much faster now that I've added in more of the sodium hydroxide. And while that's trying to equilibrate, I'll see if I can get a new reading here. Looks like 9.60. Reading 9.60. Make another addition. Have a reading of almost 10. We'll call that 9.99. Now at 10.39. I'm going to go ahead and start adding in some larger volumes here. That brings me up to 10.89. Notice the pH is much, much more stable now that we're starting to flatten that curve. And we are now at 11.89. 0.30. And if you look on our graph, we can see that we're starting to flatten out now that we've gotten up into the much higher pH. We'll do one, maybe two more additions. It won't take nearly as long for the pH to stabilize. Let's see, that brings us to 14.45. And we'll do one more addition just to kind of complete that curve up there. That is right at 16.1. And already we've stabilized here. What did I just say? 16.1. Okay, now we have a beautiful kind of an S curve. And notice the big changes in pH, pH being the vertical scale and volume being the horizontal scale. Big change in pH with a very small change in volume. Okay, I'm going to stop this run and we'll store it so that we can print, set up the next run. Let's go over here, to experiment, and we will store this latest run and we'll set up for the next one. Okay, to do that, I'm going to have to rinse off my pH probe before I set it up into this acetic acid system. And I'm also going to go ahead and top off my sodium hydroxide back up to the 0. It makes it very easy to calculate. So give me a few moments and we'll be right back.